Welcome to Mac 2311 for Engineers, Exam 4, free response number 2. So in this question, they go ahead and they give you two different integrals, and they just want you to go ahead and solve them by means of U substitution. So all U substitution says is, let's go ahead and try to substitute these terms that are in terms of x with something that's in terms of u. And hopefully, in doing so, we've simplified the integral enough so we can actually take it. Because we don't know how to take this integral as is. But what we can do is we can go ahead and say, I know that if I take the derivative of the inside of this, it'll give me this guy here, with the exception of a difference of maybe a constant. But constant's alright, because the constant you can just pull outside. So if we go ahead and set the inside of this equal to u, then we can go ahead and find out what du is. So the derivative of this is just going to go ahead and take you to negative sine 2x times the derivative of the inside, which gives you a 2. And then you have a dx at the end. So standard procedure is always figure out what you want to go ahead and use as u, and then take its derivative to get your du. Because you're going to need both of these to fully substitute into this. Now, obviously, we didn't necessarily know that this should be the u right off the bat. I mean, it just comes from experience. If you went ahead and set this equal to u, then you're going to run into some problems with the substitution. Even though you can go ahead and find out what your du is and everything, it's not going to work out as nicely. So all you do is just start back over, from scratch. So it's not the end of the world if you choose the wrong substitution, but you want to obviously get it right the first time to save yourself some time in the test. So what we can do is we can now rearrange this and say that the square root of this is really just the square root of u, because u is just that. And then dx, we know what dx is because we can actually just divide this stuff over. So if we divide this over, you can see it's going to be negative 1 over 2 sine 2x times the du. That's just all goes away. It's just what dx is. So we can plug that in for dx. So we have negative 1 over 2 sine 2x du, and then we still have this sign out over here. So you still have a sine 2x floating around here, and we still have the integral we have to take. But now you can see this sine 2x will cancel out with this sine 2x. And then this negative 1/2 we can actually pull out front. So you can see this is negative 1/2 the integral from 0 to pi over 4. And then this is gone, we pulled it out front, and then we just have the square root of u, so that's u to the 1/2. And then you have du. So now we've successfully turned this integral that was in terms of x completely into terms of u, because u and du. There's no x and dx anymore. But we know how to take the integral of that, because that's just going to go ahead and be a little power rule. Increase by 1, divide by it. So the only thing is, once we go ahead and integrate this, we can't just simply evaluate using these bounds. You'll need to either plug back in for u, so that way you get back into terms of x, and you can keep these bounds, or you can change the bounds. So that way the bounds go to like u bounds, and you can keep the u as it is. So if we integrate this, you're just going to go ahead and increase by 1, so you get u to the 3/2 power, and then divide by 3/2, which will flip it and give you 2/3. And 2/3 times negative 1/2 is just going to be negative 1/3. So you get a negative 1/3 out here. And then you would integrate from 0, or evaluate from 0 to pi over 4. But, like I was saying, you can either keep these bounds or plug back in. And when we plug back in, we know u is cosine 2x. So you plug this back in to u there, and then evaluate. Or we could just go ahead and change the bounds right now. So that's what we'll go ahead and do. How do we know what these bounds go to? Well, you just feed these bounds into this guy right here. Because it's saying like x is equal to 0 right now. So when x is 0, what is u? Well, we know this because we have a relationship between x and u. If I plug 0 in, this is just cosine of 0, and cosine of 0 is 1. So instead of using 0, I want to use 1. And then this is when x is equal to pi over 4. So we can plug pi over 4 into here. 2 times pi over 4 is pi over 2. Cosine pi over 2 is 0. So that means u is 0 at that time. So we can cancel that out and just put a 0 here. And now we can just keep it as a u. Now, it's up to you which way you want to do it. Keep the u and change the bounds, or keep the bounds and change the u. In the end, neither way is shorter. You're pretty much doing the same thing, just in a different order. So it's just personal preference. So now once we have changed these bounds, then we can go ahead and do top minus bottom. When you plug the top in, it all goes to 0. Then minus, and when you plug the bottom in, you just get the minus 1/3 here. And then you had minus that. So you really got a positive 1/3. So 1/3 is going to be the integral of this. Now, doing that same procedure, just for another problem. Here you can go ahead and see that you have x on the outside and this 4 minus 2x on the inside. Now, over here, we had it where one part was the derivative of another part. So that really shouts out u substitution. You can go ahead and actually say, oh, if this is u, I derive it, I'll go ahead and get this piece over here. So that's going to be nice. Over here, that's not the case. Because what's going to happen is, if you set either one of these equal to u, when you derive it, it's just going to go ahead and give you a constant term, and it's not going to account for this x here. So we're kind of in a little bit of trouble, or at least it seems so, when you first look at it. So what's going to happen is you can go ahead and we can't distribute this x on the inside because you have this thing to the 1/3. If this was just one unit, if say this was just x to the 1/3 and you have this stuff on the outside, then you could easily distribute that x to the 1/3 throughout the whole thing. So, but we can actually rearrange it, and that's what will happen just in terms of u once we actually do the substitution. So let's go ahead and do this, and you'll see what I mean. If we go ahead and set this inside stuff equal to u, and that's a good rule of thumb. Usually, the more complicated it is, or the nastier it is, that's going to be your u. But that's not always the case, but it's a decent rule of thumb to follow. So you can go ahead and say this was your u. So that means your du would just be, well, the 4 goes away when you derive, and you just get a -2. And you get a dx. So if we wanted to go ahead and substitute all this stuff, you can go ahead and say this is an integral, and you just have u to the 1/3, and you know that your dx would just be -1/2 du. You can just divide that over, so you get a -1/2 du. But we still have this x floating around here, and we can't have x's and u's. So how do we get rid of that x? Well, that's where there's a little bit of a difference between this u substitution method and this substitution method. Here you actually have to go ahead and rearrange, because we're saying u is equal to the 4 minus 2x, but we can actually solve for x in this equation. We can subtract the 4 over and divide the -2. So it would be u minus 4 divided by -2, and that's what x is equal to. But now we know what x is, and that's all we had was an x over here. So now we can go ahead and replace that x with u minus 4 divided by -2. And then what we can do is we can simplify this, because we can pull out the -1/2, we can pull out this -1/2, giving you a positive 1/4 on the outside. And then all you have left is u minus 4 times u to the 1/3 du. Now we can actually run that u to the 1/3 throughout this whole thing. We can distribute it, which we couldn't do up here because the multiple terms were on the inside of this power. But now the multiple terms are on the outside of the power. So let's go ahead and just write up over here. So if I distribute this through, I go ahead and get the integral of u to the 4/3 power minus 4u to the 1/3 power. And you have your du, and you still have your 1/4 out here. So now we can go ahead and integrate this. There's just going to be two little power rules, increase by 1, divide. So this is going to go up to u to the 7/3 divided by 7/3, which actually flips and gives you 3/7. You still have this 1/4 on the outside. Then minus, and you increase this by 1, so it's going to be 4u to the 4/3, then divide by 4/3, which actually multiplying by 3/4. So the 4 cancels out with the 3/4, and just gives you a 3 here. And then you get this. And then now the problem is actually an indefinite integral. We didn't have any bounds here, so you would then go ahead and put a plus c at the end. So let me erase all this. And it doesn't matter if you put the c on the inside or not. You can just go ahead and tack on a plus c at the end. So then this guy right here is going to be your antiderivative using substitution. And that's it for this problem.